Hello everyone, thank you so much for having me. So let me first share my screen to all of you and let me know if you can see it. Can you see the screen?
Yes, it is visible. It's visible.
Okay, great. So we are talking about building intelligent system today. This is in a way an introduction to AI agents, how it is beneficial or it's more useful in terms of like more than basic LLMs and prompts and such, and what we can build with it, why it matters, and at the end. I will show some of my one of my actually application that it's very simple application actually, but it really focuses on how powerful it is and how simple it is to construct to create something like that. And it's about teaching someone about language. So in this case, in my case, I created an application. It's a kind of introductory application that uses Google ADK and agent to teach Nepali language to new learners that they are from different language, in this case English. So yeah, so without further ado, let's begin. So brief intro about myself. I am Kshitiz Rimal. I am currently Google Developer Expert on AI ML. I am a Google Developer Expert since 2018, and my background mostly lies in application side of AI ML. I was part of a company called Brainly, which is an edtech company, if you have heard of it. So, my background, my experiences are mostly connected with how AI or generative AI in general can be used in the learning mechanism, how teachers, students, and a learner in general can benefit from it. And also currently I'm a CEO and founder at NextAI, which is a Nepal based consulting firm, and here also we are developing application that is in this same domain, in edtech domain. And apart from that, we are building mostly business automation tools using agentic workflow and generative AI. And if you like to connect with me, this is my LinkedIn handle, Kshitiz Rimal, and yeah, feel free to reach out. Okay, so, okay. So before we begin, let me highlight some of my past projects, and this will set why I chose that particular example at the end of this presentation as well. So my inspiration, my let's say aspiration to learn AI and to build a career around AI comes from my two of my most notable projects. One is cast recognition for visually impaired, that basically is a companion app that I developed for visually challenged, visually impaired individuals in Nepal. So in Nepal, the paper currency we have are not very friendly to visually impaired individuals. So what I did is created an app. This is back in 2018, where AI can recognize the paper currency they are holding and plays the sound of how much money they are holding in their hand, and that easily helps visually impaired individuals to perform day-to-day monetary activities, like paying to like public buses, microbuses here and such. And another is the disaster relief and response project. So in back in 2015, Nepal experienced a major earthquake, and a lot of the houses mostly in rural part of Nepal were affected by it. So what we did is we developed an app on a mobile that basically does the first level of screening of those affected houses and tells the house owner whether they can be retrofitted and or not. This hugely saves the time of an engineer coming from city area traveling to the rural just to check whether or not that house can be fixed. So in order to save the money, time and such, this app was very helpful. And this was also the second runner up app in a global competition called Call for Code, organized by IBM. And my recent research paper includes how we can train the local open source models to understand or enhance the capability of understanding low resource languages such as Nepali. In this case, I took the example of Nepali language, but this can easily be, modified or further developed into another language as well. So link is in the description and such, and I will share the slide afterwards, and you can go there and check it out. So, the agenda for today. First, we'll talk about LLMs and prompts, and then we quickly head to agents and ADK, the Google ADK Agent Development Kit, and the demo. So, it's very simple, straightforward agenda. So, yeah, so I will mostly be talking about in a way that is beneficial to first time developer or like learner in terms of agentic workflow, LLMs, prompts and such. So the disclaimer here is that it's for beginner, not for advanced user. So if you are already familiar with all the agentic tools and such, this might bore you, but for beginners I think it's a good starting point. I think someone's mic is on, so if anyone can mute it, that would be really helpful. Okay, thank you. Uh, okay, LLMs and prompts. So basically, think of it large language models as the engine that is empowering what we are experiencing today, like the heart of generative AI. So it excels at understanding the text we write, the images we give, the audio we give, and furthermore it generates in a manner that we appreciate it or it's very helpful to us. How they work? So basically, think of it as a sophisticated model that firstly develops this intuition of predicting the next word or the next entity to generate, and based on that it develops this or mimics in a way how we want the output to be. To break it down, to make it more simple, so here is an example. The generative AI that we hear around us, that is the hype of today's time, is mostly because of LLMs, large language model. And in the heart, LLM, what it does is if you give a certain sentence or words or sequence of words, basically it is doing predicting what the next word will be, and in a technical term it is called token. So a token is not exactly a word, but it could be a half of a word or the smallest part of the word. In many languages, the token can be interpreted as a single word, half word or multiple words as well, but mostly the smallest unit of the word. And basically LLM at its core is doing is that predicting what could be the next sequence in the word generation or the token generation. So if we give like roses are red, violets, it will give output like violets are blue, sugar is sweet. So this is what in essence the LLM is doing. Now based on this essence, when we train these LLMs that are like billions of parameter big and like on a huge amount of data, it suddenly acts very magical to us. Think of it, you can take the example of ChatGPT or Gemini or any other the model that we use. So basically at the heart they are the LLMs. And the biggest, I think, the valuable point of this LLM and the Gen AI is that it is driven by prompts. So whenever we are using Gemini or like ChatGPT or any other similar application, the instruction that we give are called prompts. So in technicality there are two kinds of prompt. One is the system prompt and another is the user prompt. Whatever you write in the Gemini are the user prompt, but the personality set to the LLMs, like if you go to ChatGPT or like I think the best example here is the AI Studio, Google AI Studio. So there is this UI where you can set the system prompt instruction that basically sets the personality of the LLM. So if you set a LLM with a system prompt like, hey, you are a math tutor, only answer questions regarding math and nothing else, then whatever the user writes in user prompt, it will try to assess whether the question is exactly related to math or not, and then only gives the answer likewise. So this is how we control the LLMs today with two different kinds of prompt. One, the system prompt or system instruction, and another is the user prompt. Now there are still a lot of limitations with this. So this is why we need agent, but we'll come to that later on. So one of the uh, biggest limitation I would say is that if we set a personality to LLM and gives user output, now let's say there are certain instructions or the user prompt that the LLM required to perform, but then again somehow it misunderstood it, or like with for given system instruction it understood that, hey, this is not my purview, or hey, this is not what I am instructed to do, then it will not do it. That limits the application side of the user. So LLM in itself and prompt is hugely beneficial and flexible, but at the same time there are limitations, and this is why we are coming to the age of agents, and this will be highlighted later on. Now, to just give you an overview, if you are completely new to this area, we are talking about AI. AI is this big field, and this emerging field is the deep learning, where we develop neural networks for prediction capability. So basically, the LLMs right now we are so fond of that we like is a part of generative AI, but that borrows the idea that are developed on the idea of deep learning, that in itself learn to make predictions. So the biggest difference between deep learning and generative AI is that generative AI uses deep learning model, but instead of making just prediction, it learns to generate new content as per the user prompt or system prompt. So this is one of, I think, the coolest example that I have seen, and I think this is in Gemini, the latest one. So this is a simple prompt. So when I give this the Gemini or the LLM, the today's latest LLMs, this kind of prompt, like here, a cookie jar was full, it is now almost empty. Mom made the cookies, mom did not eat any. Dad was working, dad did not go to the kitchen. Alex was playing outside. Who ate the cookies? And explain why. Now, if you have given this kind of prompt to the earlier iteration of LLMs, they might have jumped to the conclusion like, hey, it could be dad, or it could be mom, and sometimes it could be Alex. But there was no, like most of the cases, the explanation why it is so were lacking. But now with just this prompt we get a response like this from the current state of the art LLMs. So based on only that prompt, it tries to break down the situation, understand who exactly ate the cookie, right? Like it evaluated the situation, like, okay, so if mom confessed that she did not eat any cookies, or dad was working and didn't go to the kitchen, most likely it was Alex, right? So this kind of deducing capability now suddenly are emerging in LLMs, and this is purely with just user prompt and the state of the art model. Now with this kind of reasoning engine, we can be creative and create a lot of great applications. This is only the application in terms of text, but we can also develop something like image generation. This is a screenshot from ImageFX. This is in Google Labs. If you go to ImageFX, you can generate images like this, and I think it uses the latest model from Google called ImageGen 3, or perhaps Imagine 4. But the thing that I like to highlight here is that a lot of the earlier iteration of image generating model, they were quite they were good in terms of creating realistic images, but at the same time they were severely lacking in terms of creating consistent images or consistent character generation. So here one interesting thing happening here is that I have given a prompt to this model, and what I have done is asked the model to create or generate consistent character of the same person, but doing two different actions. In this case, the same character sitting in one panel, and the same character standing up in the next panel. And this is, by the way, the single picture. It's not a two picture, but a single picture with two different actions of the same character. And the output like this was not so realistic or like useful or like very interesting to us in earlier iteration of this image generation model, but now it is becoming that. And with this kind of application, what we can do is create this consistent video generation. So what I've done here is created the splitted this single images into two part, the first frame and the last frame, and given this input image input to another model for video generation from images. So with this, what we can do is create something like this kind of a consistent generation, and this is all thanks to this text understanding capability, the newer data set, the newer architecture and such, not only for the text but image understanding, image generation, and even video generation here. And something like this is like what we can do is create something like this kind of character, like a 2D or 3D animation or infographic animation, all thanks to this multimodalities. Like whenever we talk about beyond text, it's called multimodalities, right? So now the LLMs with prompts are evolving beyond text. So whether it's an image text image input or text input, in this case I have given only the text input and it has generated something like this. In my earlier slide it was the image input. So now it can create something as magical looking or interesting looking like this, and think of the application that it can provide us, right? So yeah. Okay, another something interesting is this object detection. So object detection itself is not a new application, but now thanks to Gen AI and LLMs and prompt, the same model can perform different kind of things. It can generate image, it can do the image classification, it can also do the object detection like this. So here in this case what I've done is ask the Gemini with a single user prompt and image input, and just ask the Gemini to, hey, give me the bounding boxes around those objects that I want to be highlighted, and now suddenly it is working like object detection model, right? So based on only the prompt we can see how flexible or powerful it is, the LLM itself, that we can create the application around it, right? So yeah, this is I think the highlighted part, or should be highlighted part of Gen AI. Earlier, like we have different kind of models for different kind of activities. Now what we are witnessing is a similar single model or limited set of model with flexibility with prompts to give output on our different use cases. The same model doing object detection, same model doing image generation and such. So this is very powerful and flexible. Same model can also be done to understand videos, not only images. So if I give an entire video to these LLMs with prompt, it can do like a timestamp breakdown on in which scene what is happening, all the description in whatever way we like. And by the way, the screenshot I'm showing here and here is directly from Google AI Studio. If you have not used earlier, you can, I highly encourage you to go to Google AI Studio, and there are like free tires, you can play around, use the API to build interesting application and so it's a playground kind of environment where you can quickly test your ideas, what is possible and what is not. So I highly encourage all of you to go to Google AI Studio, and this all can be done with the latest model of Gemini. Now, so in a nutshell, LLM, they are trained on large data, mimic natural output, controlled by prompts, and they are beyond text, right? So yeah, moving on. So this talk is about agent. So before we head to agent, we have to understand what the tools are. So basically, tools, as the name implies, it's a mechanism, a way to extend the capabilities of what we have just seen, the extraordinary LLM models with the prompt, right? So LLM and prompt in itself are limited by their generation ability. So no matter how intelligent the LLM, they are really good in terms of like what to generate, how to perceive, how to deduce, but they are limited to their output capabilities, whether it's image, text, or whatever modality, right? Now, because of that, it cannot do in itself the actions that we need beyond generation. So think of it like your workflow automation, business automation, call handling, sending emails, not just writing email like we are seeing today with ChatGPT, Gemini, and all that application. But what if I want to send that email to the end user as well, or set up a booking and such, or do shopping on my behalf? So This all can be done with the help of tools. They are extending the capability of the LLMs. Now, why it matters now is that, like I said earlier in one of the prompt example, we are witnessing what is called the reasoning model or the thinking model. So the earlier iteration of model were really good, but they are limited in terms of how they break down the user prompt or how they break down the user instruction. Now with the latest model of Gemini or OpenAI and such, they have this emergent capability of thinking before acting or generating, right? So suddenly what we can do is like the model earlier were capable of generating output in a text or images or whatever form. Now before doing that they can think, and they the reasoning capability is very near to, even sometimes beyond, like, or better than human reasoning capability in some cases. So they are getting really really good in narrow use cases. So because of that we can think of not only LLMs or output in terms of text or images. Now we can connect those tools and form what is called agents. So basically think of it as agent is this umbrella term, right? This encompassing term that uses LLM, the memory engine. It has its own planning model to what to do next, and it uses tools to interact with the external world, like calling some API from certain service provider, or doing some business automation or sending email and such. So here basically agent uses LLM, the reasoning capability or not, the LLM as a brain of its core part, and it has its associated memories. It could be long-term memory or short-term memory, and uses tools as its hand or working way to connect to the external entities beyond generation, and does the activity for us. So LLM processes language input, agents carried out the actions. So basically agent uses LLM, and then the LLM decide which tool to use for that certain task, and the task is carried out. And the tool can be search, code generation, calculator, or any external API, right? So yeah, so why agent? So when you create an application around just one LLM and prompt, it's very limited. Now suddenly with this mechanism of creating agent, what you can do is not limit yourself to one agent, but let's say multiple agents doing multiple tasks with multiple personality, and they all have their own tools and associated memory. So they can act like a team of human workers, right? So they are autonomous. So whenever we ask something to this kind of system, the agent decide which agent will exactly be possible to perform that task, and passes that message to that another agent, and that another agent uses appropriate tool to carry out that task. So it's not limited to single LLM. Now the same LLM can be used iteratively as a swarm or a team or a unified body to, you know connect to external tools and do the planning and such. So it is autonomous. It has this planning capability to break down complex tasks into smaller one thanks to this reasoning LLM models. It has the memory, the short term or long term memory, to decide and understand the context of what the user is talking about. And let's say, like in some certain cases, I think you might also have seen in Gemini or OpenAI, like whenever you ask something, if the LLM doesn't know, it responds like, sorry, I cannot handle that. Now agents can think of it like error handling or fallback. What could be the fallback mechanism in case the action is not carried out? So this can all be done now, and it can be specialized to do certain tasks, like handling certain business operation, and it can collaborate with different AI agents as well. So it's not limited to itself. It can collaborate to different agents, whether using the same code base or a different one. So it's a very it's like a swarm of intelligence, right, with all this external tools capability. So one, I think, very interesting application is from Google as well, and this is called Project Mariner, if you have not heard of it. So I'm not sure if you can see. Let me just try to play this video of Project
Today, I want to
Mariner.
tell you about Project Mariner. It's a research prototype exploring the future of human agent interaction, and it's built on Gemini 2.0. Like with all new technology, it's important for us to build this responsibly, which is why we're starting small. We'll be getting feedback from a group of trusted testers and using their experiences to really shape how Project Mariner evolves. Let me show you how it works. So Project Mariner works in the browser as an experimental Chrome extension. I'm going to start by entering a prompt. Here, I have a list of outdoor companies listed in Google Sheets, and I want to find their contact information. So I'll ask the agent to take this list of companies, then find their websites and look up a contact email I can use to reach them. This is a simplified example of a tedious multi-step task that someone could encounter at work. Now, the agent has read the Google Sheet and knows the company names. It then starts by searching Google for benchmark climbing. And now it's going to click into the website. You can see how this research prototype only works in your active tab. It doesn't work in the background. Once it finds the email address, it remembers it and moves on to the next company. At any point in this process, you can stop the agent or hit pause. What's cool is that you can actually see the agent's reasoning in the user interface so that you can better understand what it is doing. And it will do the same thing for the next two companies, navigating your browser, clicking links, scrolling, and recording information as it goes. You're seeing an early stage research prototype, so we've sped this up for demo purposes. We're working with trusted testers to make it faster and smoother, and it's so important to keep a human in the loop. After the fourth website, the agent has completed its task, listing out the email addresses for me to use. And there you have it. We're really just scratching the surface of what's possible when you...
So as you can see, in this way, it can do this kind of complex task. So moving
bring it.
on.
Today, I want to tell you.
Okay, so now let's talk about Google ADK. So Google ADK is this newer approach to how you design agent, how you provide tools to such agent, and this is one of the agentic framework that is provided by Google. Uh, so it's not the first framework. Like in the past there are like lots of different frameworks around agent or agentic behavior and such. So one such is BwAI or LangGraph and something like that, but this is the offering from Google, and it's also agnostic to models and such. So uh, it's not limited to only Google models. You can use another model, and one of the cool part of Google ADK is that it's really simple, and it works on the higher abstraction of how easily you can create agent. And what I'm talking about is we'll see in a demo. So basically it's a very straightforward framework uh, designed to simplify the task of agent creation or agentic workflow creation. It has all these built-in tools that allows us to see how the agent is thinking or behaving, how to debug, in which step of the process it's not working well and such. So all of that is there as a kit, and so this is why it's very interesting. So yeah, so let's break down and let's get started with it. So it's very simple to get started with Google ADK. So basically what you do is start by just installing Google ADK with Google-ADK, pip install Google ADK, and you can create a simple like a new folder structure, something like this. So you have the Google ADK, what it expects is a app folder, then the env file where you put this Gemini API key, whether it's a Vertex AI API key or the Google AI Studio. So depending on what type of approach you want to use for Google Gemini API, it can be done here. And then the name of the agent that you want to build, and here basically the two files, the init file to initiate and the agent where exactly the code lives in. So this is where we design, define, and provide tools to the agent. So yeah, it's a very straightforward project structure, and it's a very simple one, and I think it's very like easy to break down for the beginners. So it's not very overwhelming. So yeah, just a two-step process. Install the ADK, create a project structure like this, and then in this agent.py, it's very simple as well. So basically, like I said earlier, agent is nothing without its tool. So here in this case, one simple example I'm giving in the screen is like I'm creating an agent that basically does the answer generation based on Google search. So whatever I ask the agent, hey, what's the height of Mount Everest, and it will do the Google search and give me the answer, right? And it will stick to the fact. And how it does that? So basically you initiate the agent, you provide name to it, you provide which LLM model that you want to use. In this case I'm using Gemini 2.0. You can use Gemini 2.5, Flash or Pro or whatever. And the description of the agent. So what is the purpose of this agent? In this case, it's what it does is answer the question using Google search and the instruction. And this is where what I said about the system prompt or system instruction. This is the instruction that you provide as an instruction or system instruction to the LLM or the agent. So here what I'm saying is, you are an expert researcher, you always stick to the facts. So like giving answer is always, you always stick to the facts, and this is done by the tool that I have provided from Google ADK called Google search. And so yeah, it's a very like a few lines of code. What you are doing here is creating an agent, giving a description of the purpose of the agent, the personality, the system instruction of the agent as a system prompt, and the tool that you want to associate this agent with, and in this case Google search. And with that with that it's done. That you now you have suddenly the most powerful, like Google search agent that uses the Google search tool and fetch the answer for you. And yeah, so there are a couple of ways. Sorry. Okay, I am seeing some question here. Prefer model for agent training. Okay, let me handle question at the end of the session so we can talk a bit more. But yeah, please feel free to remind me. Uh, okay, so this is the main part of how you initiate the agent, and these are the supplementary or the helping part that you need to do in order to run the ADK. So yeah, like you import the agent in init.py, and yeah, basically you set the API key in the env file. And then what you need to do is, like in your terminal, set the SSL certificate before you run the ADK. And ADK already provide the agent development kit already provides the web version of the user interface to run these tools, right? So once you install the ADK and set up all this project instruction and do this, you can simply write something like ADK web, and the new web UI emerges where you can interact with the agent, and that way you can easily check the behavioral of the agent. So it's very simple, and there are tons and tons of examples on how to build from simple agent workflow to the very complex one with multi-agent workflow in Google ADK samples. And the GitHub is something like this on the screen. Feel free to go there and check it out. There are tons of examples there. And yeah, and also recently I wrote a blog about the same demo that I'm showing you guys today, and this is about Google ADK for teaching low resource languages. It's on Medium. Feel free to check this one out as well. And it's a very short read, like 7 minutes long. I have shared the code, and you can easily replicate this code on your own, and I think it's a very beginner friendly and interactive example. Yeah, so yeah, time for demo. Okay, so for that, let me head back to my code editor. Uh, okay, okay, I have seen someone raises the. Yeah, please feel free to ask. Yeah, hello. Uh,
So my question is that why we not use N8N for automations? Why we keep ourselves moving towards the code like stuff?
Well, it's depending on the use case. If you are not friendly to the code, or you are not building services around your company, like, they are powerful in its own way, right? Like, if you prefer no code tool, then maybe you are the end user, right? And you just want to automate stuff for your personal or professional level capacity. But the reason that you use ADK or any other agentic framework and you do the coding is that you are not building solution for yourself, but rather a product or services to your client or your company, right? So that way, like, I think it's yeah, it separates out the use cases. Like, one is for building custom solution, another is building like a fast automation workflow for certain use cases. And I mean, both could be equally powerful, but I think it's how you prefer, right? It's not like you only go this path than the other. So there is this option and there is another option. You are free to choose your own option. Yeah, I am getting started. Yeah, it's not ended, so I'm just trying to, yeah. So what I have done is that the code is very simple. I'll just try to show you what I have done with the demo, and yeah, I will share the link and everything that you can try on your own at the end. So let me present something else. So window, okay. So here, okay, now, so what I'm doing here is that it's basically I have repurposed the earlier code that I've shown you that uses the Google for like Google search. Instead of that, what I've done is given it a new personality. So in this case, what I've done is created a new system prompt that instruct the LLM to behave like a tutor of a language. So this is very comprehensive prompt that I have written. This is the system prompt that I have written for my agent. And what I'm trying to do here is that in a communication way or in a communicative style, teach the new learner about this new language that I'm teaching through the agent. So everything remains the same, the project structure, the agent.py. Only difference is that I'm not providing any external tool in this case. I just want to communicate with this agent and provide a new personality, and that's it. And with this, what we can do is simply say ADK web, and let's see if it works. By the way, I have shared the code. I will share the code and everything, so you can feel free to like roam around, modify it in your own way. So yeah, so I have created this ADK UI. Okay, let me share the screen again. Okay, I hope you can see the screen. Okay, so I'm using the same agent that I've created. So here, basically the demo is something like I will enable the token streaming so that the response is faster. And yeah, so I can, instead of just writing, I can also talk. So I can use something like this. Namaste.
Namaste. That's a great start. It means hello. Have you learned any other Nepali words before?
No.
All right, no worries. We can start with the basics. How about we learn a couple of new words today? Would you prefer to learn words related to greetings or something else like food or travel?
Maybe food.
Okay, food it is. Let's start with the word for water, which is pani. Pani. Can you try saying that?
Pani.
Perfect. And now, let's learn the word for food itself. It's kana. Kana. Can you try that one?
So here, so in this way, like so in this way you can easily create this kind of complex application. So this is a very short demo, so the detail of which is shared in this blog, this Medium blog. So here I have set out all the steps that it is required to run this example on your own, how to install it, what's the system prompt like, and everything. So feel free to go there in your own time. And what I have just shown you is the Google ADK web UI. You can also create your own UI and something with fast API or UVCon or something like this, which I have done in this blog post. So it's either way. So you can create API around it and with your own UI, or you can use the Google ADK web to debug the agent behavior and such. So this is I think very simple, straightforward application. Yeah, and yeah. So okay. So yeah. This is it. Yeah, this was my short presentation today. So if you have any question, I'm here to answer. Thank you. Okay, let me share this code or the Medium blog on my chat. So if you can see the chat, this is the Medium. Yeah, there is the code and instruction and everything. So I see some question here. Okay, how to get the code, share the link. Yeah, so this is the link, and yeah, feel free to ask the question. Okay, okay, so good question. Is it free or do we need credits for it? If you use Gemini, there are like free quotas, and I think this is very generous free quota from Google AI Studio. Simply go to Google AI Studio, and there are like the limits are very generous. You can try different kind of models, and you can create prototypes around it very quickly. But you can also use open source model with the same framework. So it's not locked on like Google models. So you can use your own model as well if you have. You can use OpenAI SDK. I think like I said, like it's how you prefer to build your application, right? So it's not like one solution that is better than the other. There are like different flavors or different way you can create the same agentic workflow. Google ADK is just a newer addition, and in a lot of ways it's very fast, and it's very in an abstraction way it's very easier to get started. But if you are already familiar with OpenAI SDK and any other framework, feel free. I think the end goal here is to create the powerful AI agent in whatever way you are comfortable with. But yeah, given all the pros and cons of every other framework, like you can figure out, you can try it out and see which one best works for you. Yeah. You can also use OpenAI models in this case. Yeah, it's not locked to the Gemini model. So yeah. How do we give an external functionality to the agent which is not already provided by Google ADK tools? In this case, you have to create your own tool, and I think there are like docs around it or like instruction how to create your own tool. So basically, you create a wrapper around the tool and provide uh, as a argument to the agent. So yeah, think of it as your own endpoint that the agent needs to interact with. Yeah. So you are not limited to whatever is already provided, but you can also create your own. How to get started in Zen AI and how to build my portfolio as an agentic developer. So in this case, what you can do is explore as much use cases, frameworks, models, their capabilities as much as possible, and develop projects around it, blog posts, speak in events like this, and yeah, and talk to like-minded individual, collaborate on project. I mean, it's not a very straightforward path or the answer, but I think it's the time that you spend following your own curiosity, and keep an eye out for the newer models, newer frameworks and such, and just publish whatever you do. And yeah, I think it's a good start. Which things should be looking at while choosing an LLM model? Uh, so at this point, a lot of models in general sense are very comparable. Like there are like some cases where, like in, let's say for code generation, you can see leaderboard scores on Hugging Face or any other standard leaderboard arena or something like that, and decide which exactly application that you want to build this LLM around, and pick that LLM. Like for example, code generation, I think Cloud Code is, I think, very useful and very like appreciated in general in on the internet. Gemini 2.5 Pro is excellent but slightly on expensive end. OpenAI O3 is also very intelligent and in terms of reasoning and code generation, but it takes a lot of time. So there are like pros and cons. Like some models takes lot of time, some models are good at something. Like for example, for image generation, for a specific kind of image generation, OpenAI 4 model are really good. Like whenever it's about generating images with text and consistency, OpenAI for image generation is really good. But when it comes to creating very fast and realistic artifacts and things that you want to use for browser or something like that, Gemini image generation is equally good. So it depends on the use case, right? So yeah, I think the first thing that you can do is check the leaderboard and how different models are performing on different areas, right? And that way you can best pick the model and modify or create a use case around it. I mean, like, are there any parameters through which we can know which model is good and how good? So there are scores in this leaderboard, right? Like, yeah, can you share some evaluation criteria which should be considered during selection of model? So if you go to Hugging Face, if you're not familiar, Hugging Face is this space where the open models are hosted and there are spaces around it and there are arenas around it. So go there, check the arena, check the scores on different parameters. Some good at math and science, some models which are relatively good at math or science, their scores are quite high. And like, so it's not like this score is good for everything, right? So yeah, it depends on data set they are tested on and such. So it's not a very straightforward answer, but yeah, you have to do some research on your own and see like which area that you want to tackle. Yeah, yeah, please feel free to ask. Yeah.
So my question is that there are two way of making any agent. Like one way is to learn coding and do some coding, and the other way is to learn just an N8N, and other one is Zapier.
Mhm.
So what should you recommend me to do, like when I have to make any agent? Which
Okay.
is the best way?
uh, I think like I'm giving you this idea from my perspective, right? So if I were you, I will first understand the capabilities of agent. So N8N or Zapier or something like no code tool would give me good idea what agent can do in itself and what it cannot do, right? So once I develop this intuition, like the use cases and what kind of use cases I can develop around this agentic behavior, then I will head over to the coding part where I will create my own services or my own application with custom tools, LLMs and such that others can benefit from, right? So as a learner, first understand what particular LLM can do, like the prompt handling, how well it generates certain contents, or for in terms of agent, which LLM to connect that agent with, and what kind of prompt to do, and what is the like the maximum capacity of doing certain use cases that you dream of doing. And if it works, then think of it like translating this to your own code and creating your own solutions around. Okay, if you don't have any other question, I hope this session was somehow useful to you and you enjoyed the session. Thank you so much for having me.